Time again. It's Math with Mrs. Peters, the crazy cat lady of Hiram High School, and today's topic is simplifying radicals. So, I have a radical here on the board. Its index is 2, though it's not written, because right here I would have a little 2 or a little 3 or 4 or 5 telling me if my index was a different number. But right now, since it's not written there, the index is 2. And that means I need perfect square numbers to be able to rewrite this. So let's look at 16, and I'm going to factor 16. Right. Not with my highlighter, of course. I'm going to do it with my pen. Okay, 16. Well, 16 is 2 times 8, or 2 times 4, and 2 times 2. Now, I'm going to only select my prime numbers, because it's actually a whole lot easier to simplify a radical if you look at it with its prime. So the square root of 16 actually is 2 times 2 times 2 times 2. Now I'm looking for perfect squares. That means I need 2 of a number that looks exactly the same to get something out from underneath the radical. So what I need to do is circle my perfect groups of 2. Okay, they get to come out from underneath the radical, and what I end up with is 2 times 2 and a radical with nothing underneath it. Well, if I have a radical with nothing underneath it, just take my handy duty eraser and get rid of the radical. Now 2 times 2 is what? Oh, you say 4. Okay, excellent. Yes, the square root of 16 is 4. Some of you sort of already know that on the inside. The reason I'm going through this prime number issue is so that we can look at it when we start getting letters or variables up underneath that radical. So let's look at another type of problem here. Okay, I have the square root of 75. Now, if I do a factor tree, and I'm going to do one really quick here, let's see, 75. Well, 75 is 3 times 25, and 25 is 5 times 5. So, the square root of 75 is 3 times 5 times 5. Okay, I do my little grouping of my perfect 2 group. Okay, the 5 gets to come out underneath. So I have a 5, and then anything left underneath the radical stays there. So the square root of 75 is 5 times the square root of 3. Now, let's do one with a number already on the outside. 5 times the square root of 80. Well, that means I'm going to have to factor 80. Now, let's see, that's 8 times 10. Neither one of those are perfect. 10 is 2 times 5, and these are prime. And 8 is 2 times 4. 2 is prime. And 4 is 2 times 2. Okay, so the square root of 80, I'm not going to forget to put my 5 on the outside, is 2 times 2 times 2 times 2 times 5. I group my perfect groups of 2. Each one of those get to come on the outside. All right, so what I have is 5 times, and I'm going to color those 2's in blue so you can see them. And what I have left underneath the radical is the square root of 5. Now, we need to compute 5 times 2 times 2. So this piece right here becomes 20. Square root of 5 does nothing, and so 5 times the square root of 80 is actually 20 times the square root of 5, and this would be my answer. Now, okay, Mrs. Peters, I get what you're talking about. So let's talk about ones that are a little bit more difficult. I threw a letter in here. Okay, now we've talked about the square root of 80. As we talked about the square root of 80 over here, and we took and factored it, the square root of 80, right here. Square root of 80 is 2 times 2 times the square root of 5. So I'm going to use that information. I'm not going to repeat myself, not if I can help it. So what I have here, don't want to use the highlighter, I want to use a pen. I have the square root of 2 times 2 times 2 times 2 times 5 times p times p. All right, now group by my groups of 2 exactly alike items. All right, bring them on the outside, and that is, same rule goes for the p's. So this is 2 times 2 times p times the square root of 5. Okay, and when I take care of this piece, I get 4p times the square root of 5. Oh, okay. I'm just following the same rules. Okay, the same rules that we did for the square root of 16, I'm doing for the square root of 80p squared. So let's do 200. Without doing a factor tree, I have 2 times 20. Nope, I'm going to have to use the factor tree. Either that or get out a calculator, and I don't feel like having a calculator out right now. 2 times 100, which is 10 times 10, which is 2 times 5, 2 times 5. So the square root of 200 is 2 times 2 times 5 times 2 times 5. Now, I have 3 a's times a times a times a and a p. You're going, Mrs. Peters, you didn't write them nicely. Well, we can still group. Here's a group. Here's a group. And I want to do this one in blue. And here's a group. So, pull those on the outside. I get 2 times 5 times a. Okay, and left inside my radical is a 2, an a, and a p. So I have 10a square root of 2ab. And we're done. You have simplified some radicals. That's it. Hope you have a good evening. Talk to you later. Bring your questions to class, and see you in tutoring. Talk to you later. Bye.